Showing up? Oh, wonderful. So is it macro, micro, or nano? That's the name of this topic. So here's an example of something that's macro. Everyday objects you can handle with your hands. This is micro. Anybody recognize this? It looks like a gear, doesn't it? Okay? Each gear tooth is about 8 microns wide. Okay, so that's micro, microns. 8 microns. Microns, 10 to the minus 6, 8 of them. Okay? Gold dot on the end of a cantilever. You're going to have a cantilever experiment this semester. The gold dot is 50 nanometers across. 50 nanometers. Okay, that's nanoscale. Less than 100 nanometers is considered nanotech, nanoscience. That's the Intel definition. Less than 100 nanometers, it's nanotechnology. Above 100 nanometers to 1 millimeter is microtechnology. Okay, that's their definition. There's lots of definitions for micro and nano. Okay, and we'll talk more about that throughout the semester. So what are you going to do? We're going to do an activity today that will provide an opportunity to work with objects in 3 scales: macro, micro, and nano. Okay? You're going to identify objects that fit into different scales. It's to give you a gut feeling of what a nano is and what 100 nanometers means and what 1 micron means. Give you a better feeling. You're going to have to fill in a chart that says, okay, give me an example of something that's about this big. So it gets harder, right? It gets harder as you get smaller. You've got to think of stuff. Is a virus 10 nanometers or 100 nanometers? What about a bacteria? What about a cell wall? What about the width of a hair? All of these things are examples of small stuff. Okay, so you're going to be doing that today. So examples would be like there's micro pumps and there's macro pumps. The pump you have to pull water out of your well is macro, it's big, right? And you might have a microfluidic pump if you're an insulin user and you have an insulin pump, okay, that provides you with insulin periodically. Anybody have an idea what this is? What's this look like, this big structure here? Diving board. Excellent. It's a diving board. You're absolutely right. The mechanical engineering term for a diving board is a cantilever. It's a bridge that's only attached at one end. It's attached at both ends. They call it a bridge. Okay, so mechanical engineering term, right? It's also a MEMS term. A cantilever is used in tons of MEMS devices. So you're going to have a lab on the cantilever. And you'll really like that one. That one's kind of fun. Okay, we're still getting into the introductory stuff. Too much talking, right? Not enough hands-on. Well, that's a cantilever. And it's got some stuff stuck to it. Okay? It's also a MEMS sensor array. So you have different cantilevers that are coated with different materials, and different things stick to the different cantilevers. So if something sticks to a cantilever, it changes its mechanical properties, and you can measure that electrically. So your electronics guys and girls, I shouldn't use the word girls, sorry. Your electronics technologists, right? You're not really technicians anymore. Technicians are more like, in my mind, computer repair technician. You're more than that. You're a technologist. You have a broader sense. So you have these things coated with different things, and if something sticks to it, the mechanical properties change. As a result, you can measure it electrically. And you'll have some units on how that's done. Okay, but we can measure very, very small amounts of material on these micro cantilevers. So the cantilever is micro in size. This might be, I don't know, 10 to 20 microns wide. This is not a very good and accurate scale. And then you see large things, smaller things on here, some kind of a coating, So that could be antibodies, antigens, right? So if you coat it with certain antigens or antibodies, and the complementary will stick to it, and then it changes its mechanical properties. Okay? So how big is it? All right, here the answer to the $40 question. 50 microns, approximately the length of it. I use the term microns. Most people in the industry use microns. It stands for micrometers. That throws people sometimes. They see micrometers and they go, huh? Micrometers, microns, same thing. Micrometers, microns are the same thing. So how big is it? Macro. Anything over 100 micrometers. Micrometers, micrometers. Micrometers, you guys might know or refer to a micrometer as a measurement tool, right? A micrometer. It's got a little screw thingy on it. You can measure the thickness of stuff. You probably use them all the time. Sometimes. I have some micrometers somewhere. I'll bring them in one day. You can play with them. What's micro? Any ideas? It's a range, right? Yeah, we'll call it anything above 100 nanometers and less than 100 micrometers. Or microns, or micrometers. Okay, I repeat myself a lot. Hopefully some of it will stick. And nano? What range do you think it is?
Everything below 100 nanometers.
Yeah. Some people say between 1 and 100. When you get below 1 nanometer, things get really weird. You know, you have individual molecules. So it's more molecular chemistry than it is nanotechnology or nanoscience. Okay? Anybody know what this thing is? Tail of something? Oh, look at the clues. You got a cell wall. But then look at some of the labels. Stator. The stator. It's part of a motor, right? You know, they used to say man invented the wheel. This is a wheel. It rotates in one direction. So biology invented the wheel. It's a bacteria, more specifically a bacterial flagella motor. The stator is anchored to the cell membrane and encloses the rotor, which turns at a rate of 1,700 revolutions per second. That's a pretty good motor, huh? And it's small. How big is it? Or how small is it? Depends. Is it half full or half empty, right? The rotor is 50 nanometers. So that cantilever you saw was 50 microns. This is 50 nanometers. I'm going to ask you something. How many orders of magnitude smaller is this from the previous 50 micron thing? 1,000 orders of magnitude? 3 orders of magnitude? Okay, who says 3 orders of magnitude? Raise your hand. Who says 1,000 orders of magnitude? Raise your hand. Come on, you all have to raise your hand. Make a stab at it. It's like a game show, right? How many say 1,000 orders of magnitude? 1, 2, keep them up. 1, 2, 3, 4, 5, 6, 7. How many say 3 orders of magnitude? 1, 2, 3, 4. So democracy doesn't work in science. It's 3 orders of magnitude, right? An order of magnitude is a factor of 10. You have 3 orders of magnitude, it's 10 times 10 times 10, which is 1,000. Okay? So 1 order of magnitude is a factor of 10. Very good. All right. So let's see. Nothing new there. Okay, now here's something. This is micro. Is it macro, micro, or nano? There's 2 different pictures. Now this is really hard for you to judge, right? You don't know what it is. Any guesses what the thing on the left is?
Test tube.
Test tube, carbon nanotube. What's a carbon nanotube?
It's a matrix of carbon atoms that usually form into a tube of course, but sometimes they're gaps and sometimes they're not.
So this is a representation of the carbon structure. So the carbons are at the corners, right? And these lines represent the bonds. So very good. Carbon nanotube. Okay, it's a type of fullerene. You'll learn about fullerenes sometime in this semester. The one on the right, any guesses? I couldn't guess this one. A hair? Not quite. It's a stent. So they put that in your artery when your, cholesterol's high like mine. They haven't done that yet, thank God. But they put that in and it expands and it opens up your artery or vein so the blood can flow. It's called a stent. Which one is bigger? The stent, right? That's what you would think, and that's what you're right. Carbon nanotube, the diameter is about 2 nanometers, so it's nano. And then the arterial stent is 4 to 12 millimeters in diameter, so it's micro. This is a really cool technology. I know a guy in California who's working on stuff like this, and now they're putting drugs in the stent. They're coating these things to, and the drugs help keep your arteries clear. So that's pretty cool. We're becoming Borgs. So what about this? This is hard to judge, right? I'm not even going to let you guess. Could be anything. So the thing on the left is a floor plant tray. So each one of these little squares is about a centimeter. This is a $60 question. How many microns are in a centimeter? Centi is 100th. Microns is 1 million. The difference is how many zeros? 4 zeros, 4 orders of magnitude. Okay, so 10,000 microns are in a centimeter. 10,000 microns. If you work on the design team project, the smallest structures are 1 micron that you design to. Okay, and that's most MEMS companies can go smaller now. The thing on the right is a MEMS regenerator for cooling. So these are little cooling cells, and they're about 100 microns across. Okay, so it's macro micro. All right, so we have an activity that you're going to do. And you can be in groups of, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Did I do that? 2, 4, 6, 8, 10, 12, 13. 2 people snuck in after the 11. So if you're the 12th or 13th person, you still need to sign in, I think, if you haven't. Anyway, we've got 13 people. We're going to do groups of 4. So it should be at least 3 groups. Well, let's make groups of 3. And we'll have 4 groups, and one of them will have 4 people. And I'll let you guys figure that out. Okay? And I'm going to pass out an activity. Your job is to assign someone to read it. Okay? So there's 4 booklets, 1 for each group, so somebody can read it. And each of you will get 2 sheets. Okay? One sheet's got a complete matrix. The other sheet has part of a matrix and a ruler on it. Okay, you're going to think this is kind of lame, but it's actually kind of fun. So you guys can distribute that to the groups. Each individual should have a matrix. Okay. So what you're going to do, in a nutshell, and I want you to read the instructions so you get everything in detail. But what you're going to do is, on that second page, you have a ruler. So just cut the page off and then cut the ruler out. And then you're going to start cutting the ruler in half progressively. So it starts at, I think, 20 centimeters. So you cut it in half, it's at 10. You cut it in half, it's at 5. And you're going to keep going until you can't cut anymore. And I do have scissors. Okay, safety. What are some things you don't do with scissors? Now you guys remember. So I got 1, 2, 3, 4 scissors. Okay, so you can have one person in each group try to cut. You can all do it. See how far down you can go. It's kind of fun. Okay, so you can go as far as you can. But please, read the instructions completely. Okay, so the 4 booklets goes one with each group. And we've got desks up here. I can clear some of this stuff. So you've got plenty of desk space. You can move. Please feel free to move desks around and stuff like that. I don't have a problem with that. Okay. And you've got until, let's see, you got about an hour, a little less than an hour, and then I'm going to talk a little bit about homework. All right?